Hello and welcome to another video in my raspiBackup channel. In this video I want to explain why the rsync backup type is the default type of raspiBackup, because actually it's the most efficient backup type to use. There are a lot of people using tar or DD, but I want to convince them to use rsync instead of these backup types with this video. Okay, so I created a slide which I use to explain the way rsync together with hardlinks works. Because a lot of time I get some feedback and the users of raspiBackup ask why do I see that the backups are still using the same size as every time, but actually whenever you use rsync you get a delta sync and not that much space is used. So I want to try to explain how this works. So over here you have the different backups which are created over time. So this is the first backup, which actually only creates a backup of 2 files. Then the next backup created a later time, and the file 1 is updated. Then in the next backup the file 3 is added, and so on and so on. So let's describe what's going on whenever you create a backup with rsync. These arrows actually should depict the links in the directory, in the backup directory, to the existing files. So if you create a backup and there exist 2 files, 1 and 2, the first time, well, these files are copied from the source into the backup directory, and they are linked with these arrows, the green arrows, because they are created here. Okay, so next we have an update of file 1. Now rsync detects that file 1 was modified, so the modified file is copied from the source to the backup space, and there's a link created to this file. And next rsync detects that the file 2 wasn't modified, so it just creates a link on in the backup space from to this file 2. So this file is not copied. Next we add another file 3 on the source, and now rsync again starts and detects, okay, we have a modified file 1, but we already have it on our backup space, so we just create a link and don't copy the file in this backup directory. Same happens for the second file, because it also already exists on the backup space. Just a link is created and that's all. And finally rsync detects, okay, there's a new file. It's copied from the source to the backup space, and a link is created to this one. Next, the next backup F3 is updated. Now rsync starts again, detects file 1 still wasn't modified, so it's just creating a link to file 1 because it already exists on the backup space. Same happens for file 2. And okay, because file 3 was modified, it's copied to the backup space, and a link is created in this backup directory. Next, in the backup, this file, modified file 1 is deleted, and another one, file 4, is added. So what happens now? rsync detects file 1 is deleted. Well, I show an arrow saying, okay, it's deleted. Actually, a link to this file is not created because it's not detected anymore. And then file 2 exists already on the backup space. A link is created. Everything is fine. Next, same happens for the modified file 3. Just the link is created. Nothing is copied. And finally, okay, there's a new file, and then this file is copied to the backup space. Now another backup happens, and file 4 is deleted. Now again, rsync checks and detects, okay, file 2 already exists in the backup space, just create a link. And file 4 was deleted, so just ignore this one and don't create a link for this. And file 3 modified still exists on the backup space and also on the source, so just create a link. And when backup directory 6 is created, no data is copied from the source to the backup space. Okay, so let's have a look on the file system, because I created also the same structure on the file system, on my demo system. Oops. Here we are. So we can see we have in backup directory 1, file 2, same in backup directory 2, in 3 and 4 we have 1, 2, 3 file. In backup directory 5 we have deleted file 1 and added file 4, and in backup directory 6 we deleted file 4. So let's now check the file contents. I created these files and just wrote, I think, 1,000 lines of this informational string. So you can see in file 1 we have file 1, and in file 2, oops, we have file 2. And if we look into the directory, we can see, okay, we have file 1 and file 2, and both of them need approximately 11K bytes for their storage. Okay, so now let's look into if in the second backup directory, as you remember, we modified, or the file f1 was modified. So let's check f1. Okay, you can see it's f1 modified, and f2 still has the same contents. So if we now go to backup directory 5, where we also should see a modified file 3. let's check F1. Okay, it's not there because we already deleted it. Let's execute analysis. So we have file 2, still the same contents. We have file 3, which was modified. As you can see over here, we have a link to the modified file. And file 4, okay, that's the new one we created over here. Good, so you can see the files on the directory represent my slide. Now let's see what we get displayed whenever we execute a command to see the contents. Oops. Okay, okay. So in backup directory 6 we can see we have file 2 and file 3, and we can see that every file contains or requires about 11K, 12K of bytes. But as you can see over here, actually there are only links used to the files, and so we don't see the actual used space by these files. A quite nice way to see what is actually used on the file system is the command to du. So if we use dus, we can see in the first backup directory we have 2 files. Remember, a file requires approximately 12K, and there's some additional space required in order to store all these links and so. But actually we can see, okay, over here we have 2 files which need space on the disk. Here we have only one. We also have only one in backup directory 3 and 4. Same for 5. And we don't have anything, mostly no space required for backup 6. So, well, quite easy to understand. In backup 6 we don't have any file, we just use links. In backup directory 1 we have 2 files, and in all the other backup directories we just have 1 file required on the disk space. And that's why we see over here 2, and over here 1, and over here no space. There's an additional option for du which actually displays the space which will be used if no hard links are used. So you can see in backup directory 1 and 2 we have 2 files. In backup directory 3, 4 and 5 we have 3 files, and in backup directory 6 we again have only 2 files. Okay, so over here we have 2. Over here in backup directory 6 we have a link to file 2 and file 4, so we also only have 2 files. But in backup directory 2 we have In backup directory 2, we also have only 2 files. We have a link to file 2 and we have a link to file 1. But for the next 3 backup directories, we have 3 links. We have 1 link to file 1 modified, we have 1 link to file 2, and we have 1 link to file 3. If you check it for backup directory 4, we have 1 link to file 1 modified, we have 1 link to file 2, and we have 1 link to file 3 modified. So that's the way to check actually the required space and the needed space on the file system level. So just use du-sl to see the space required or used if no hard links are used, and if you remove the L, you will see the actually allocated space required for these files. So what's the benefit of rsync? Well, I already told you about this. Only modified files are copied, so the backup time will be used, in particular if you have huge files and they don't have to be copied. Well, the backup process will be much faster. In addition, due to the usage of hard links, the backup space actually used on the backup space is much smaller than whenever you use tar or DD backup, because these backups are full backup, whereas the rsync backup is a kind of delta backup, because if the files already exist on the backup space, they are not copied and not allocated and just linked. And so you save a lot of backup space whenever you use rsync. There's another benefit you get if you use rsync in contrast to DD and tar, because the backup directory actually is a normal file system directory. And so you can easily access any files in the backup. That's what I showed you already. So I can just show the contents of any file in the backup directory, and in particular if you don't need to restore the whole backup. A lot of time this happens because you just need some etc config files from a backup, or just want to check what was configured in an older backup. Just go into the backup directory, look up the file, see the contents, and you're fine. If you use DD or tar, you have to extract the file every time, which takes time, in particular if the backup is huge. So again, use rsync whenever you can, and you will be happy, and it's much easier to use rsync. Saves your time, saves space. Okay, so hope I have convinced you to use rsync whenever it's possible, and also have explained to you how all the stuff with our links works. Okay, so bye.